Hello, today we will proceed to chapter 5. The topic we are going to discuss is random variable. Random variable. The word variable means an element or factor that can be changed or not fixed. Random variable is a variable with numeric value or numbers that can be determined from a random phenomenon. For example, the number of students in the class who walk to school. If the class has 20 students, we have 21 cases here. Okay, maybe 0 of the students in the class who walk to school, maybe 1 of the students walk to school, maybe 2, maybe 3, and so on. Usually, we will use the capital X to represent the random variable. Another example, the mass of the fish in the pond. X is the mass in gram. X is a value in the interval from 500 to 700 grams. There are two types of random variable to be studied, namely discrete random variables and continuous random variable. A discrete random variable has countable number of values, whereas a continuous random variable values between a certain interval. Example for discrete random variables are number of students absent, number of girls, number of ice cream sold. Example for the continuous random variable, okay, for example, are height, mass, mark, price, or time. For the discrete random variables, for example, the number of gold, 1, 2, or 3. Okay, the number is fixed and do not have interval. Okay, for example, do not have 1.5 goals or 2.5 goals or 3.3 goals. Okay, only 1 goal, 2 goals, or 3 goals. For the continuous random variables, for the example height, okay, in between 1.4 meter and 1.8 meter, there are infinity or so many numbers in between 1.4 meter and 1.8 meter. Let's discuss a question. Write down all possible outcomes in set notation. For each of the following events, determine whether the event is a discrete random variable or a continuous random variable. Explain your answer. Okay, for A, a fair dice is thrown 3 times. Given X is a random variable, which represents the number of times to get the number 4. Okay, the fair dice is thrown 3 times, and then the number of times to get the number 4. Okay, the number of times to get number 4 is countable, so it is a discrete random variable. Okay, since the dice is thrown 3 times, so maybe 0 times to get number 4, maybe 1 time, maybe 2 times, or 3 times. Okay, so the X 0, 1, 2, or 3. Okay, we write our answer like this. Okay, in set notation, X equal to set notation 0, 1, 2, 3. Okay, and then we explain the event is a discrete random variable because its value can be counted. Example B. Okay, X is a random variable which represents the time taken by a pupil to wait for his bus at a bus stop. The range of the time taken by pupils is between 5 to 55 minutes. Okay, so this is about time taken and the range of time. Okay, so it is uncountable. Okay, so it is a continuous random variable. Okay, we write our answer like this. X is equal to X, where X is a time in minutes. X in between 5 and 55. Okay, if in between, that means no equal here. Okay, we explain the event is continuous random variable because its values lie in between 5 and 55 minutes. Another example, in a factory, a supervisor wants to check the quality of a certain product at random. There are 3 type J products and 5 type K products in a box. The supervisor will randomly pick one product and the product type will be recorded. The product will then be returned to the box and the process is repeated 3 times. Let X represent the number of times type K product is inspected. Okay, so for question A, write X in a set notation. Question B, draw a tree diagram to represent all the possible outcome of X. Okay, so C, list the distribution of the values of X together with their respective probabilities in a table, and then draw a graph to show the probability distribution of X. Okay, so the question asks to write X in a set notation, and then draw a tree diagram, and then we have to find probability. So it is about the probability. Okay, we have to draw a table and draw a graph. Okay, so we find out the info from the question. So the question said that there are 3 types J product and 5 type K products. That means altogether we have 8 products. Okay, so we can write that probability to get J is 3 out of 8, 3 over 8, and then the probability to get K is 5 over 8. Okay, and then the question tells that the process is repeated 3 times. Okay, that means 3 times of inspection. Okay, so and then X represent the number of times type K product is inspected. Okay, so type K products. So for question A, write X in a set notation. Okay, so if the process is repeated 3 times, the X can be 0, can be 1, can be 2, or 3. So we write that X equal to, in set notation, 0, 1, 2, 3. Okay, so this is for question A. For question B, draw a tree diagram to represent all the possible outcomes of X. Okay, before we draw the tree diagram, okay, we list down the info first. Okay, X represent the number of times type K product is inspected. Then we have 3 times of inspection, so that X is equal to 0, 1, 2, 3. Okay, as we have discussed before, and then we know that probability to get J is 3 over 8, and then the probability to get K is 5 over 8. Okay, so before we draw the diagram, we list down the times of inspection. Okay, so we have 3 times of inspection. So first inspection, second inspection, and third inspection. Okay, so for the first inspection, we have 2 possible outcomes. So J or K. Okay, the probability for J to get J is 3 over 8. Then the probability to get K is 5 over 8. Okay, after this, for each of these outcome, okay, we will branch out. Okay, so this is the these are the second inspection. Okay, so for J, we have 2 possible outcome, J and K. Then we write down the probability to get J and K. Okay, for this one also. Okay, we branch out to J and K. Okay, and then we write down the probability. Okay, so for the third inspection, okay, the same. Okay, we branch out J and K for each of these outcome of second inspection. Okay, so we will continue until we get a complete tree diagram. Okay, now we have a complete tree diagram. So after this, we will calculate the possible outcome. Okay, since we have 3 inspection, so the outcome is like this. So J, J, J. Okay, so the first outcome is J, J, J. The second outcome is J, J, K. Okay, so we write down J, J, K, and then J, K, J. Okay, after this, J, K, K. Okay, for this one, K, J, J, and then K, J, K, 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 J, and K, K, K. Okay, so after we list down, okay, so all of these we have 8 outcomes. Okay, after this, we find out the number of times type K product is inspected for each of these outcomes. Okay, so for JJJ, okay, the question is asked for number of time K k product is inspected. Okay, so we just refer to the k. So for JJJ, there are no k here, so 0 times. So for this one, 1 time. Okay, for this one, JKK is 2 times. Okay, this one 1 time, 2 times of k. So this one we have 3 k's. Okay, so after this, we find out the number of this case. So for x equal to 0, we only have 1. Okay, so it is time 1. So for x equal to 1, they have 3. 1, 2, 3. 3 times. Okay, for x equal to 2, 1, 2, 3. So there are 3 times. Okay, for x equal to 3, okay, occur only 1 time. Okay, so this info will help us to find the probability for each case after this. For question C, list the distribution of the values of x together with their respective probabilities in a table, and then draw a graph to show the probability distribution of x. These are the info we get from question B. Okay, x equal to 0 times 1, okay, only 1 times. Okay, x equal to 0 means no k, okay, because x represents the number of time type k product is inspected. If x equal to 0 means no k, the outcome is JJJ, okay, so times 1 because only one outcome of JJJ. Okay, for the case x equal to 1, okay, there are 3 types of outcomes. Okay, so KJJ, JKJ, JJK. Okay, x equal to 1 means k occur once. Okay, for the case x equal to 2, okay, the outcome is KKJ, JKK, KJK. Okay, so there are 3 types of outcomes, so multiply by 3. For the case x equal to 3, only one outcome, KKK. Okay, after this, we need to construct a table and fill in the table. Okay, before this, we need to calculate the probability for each of these cases. Okay, for the first case, probability of x equal to 0, JJJ. That means 3 over 8 will occur 3 times. So 3 over 8 times 3 over 8 times 3 over 8. Okay, the answer is 0.0527. We fill into the table. And then for the case x equal to 1, the probability is, okay, k occur once. Okay, so 5 over 8 will occur once, and then 3 over 8 will occur twice. Okay, multiply by 3 because there are 3 types of outcomes. Okay, the answer is 0.2637. Fill in the table. And then for the case x equal to 2, okay, k occur twice. So 5 over 8 will occur twice. And then 3 over 8 once. Okay, 5 over 8 times 5 over 8 times 3 over 8. Okay, so there are 3 types of outcomes. So we multiply by 3. The answer is 0.4395. Okay, fill in the table. Okay, for the case x equal to 3, KKK, that means 5 over 8 will occur 3 times. 5 over 8 times 5 over 8 times 5 over 8. The answer is 0.2441. Okay, fill in the table. Okay, to check the answer, we can find the sum of these probability. Okay, so the total probability of these probabilities should be equal to 1 or very close to 1. Okay, because the total for the probability is equal to 1. Based on the table, we can draw a graph as shown. This is a graph like a bar chart. The graph drawn is with separate lines. So we have 4 separate lines here. We need not connect the points because the x is a discrete random variable. There is no relation amongst the points.